Okay, ladies and gentlemen, my name is Hosea Njoku, and my tutoring session today will be on tackling some questions on biostatistics. Alright, our first question today goes like this. Question 1. A study was conducted to assess the risk of LDL on cardiovascular related issues in 400 patients. Serum LDL was found to be normally distributed among the patients with a mean of 220 mg per deciliter and a standard deviation of 10 mg per deciliter. How many students are expected to have a serum LDL of greater than 240 mg per dl? So this is a question on the normal distribution. On the normal distribution curve. As you can see, they've already given us the mean, they have given us the standard deviation, and now they're asking us for how many students are expected to have an LDL of greater than 240. So what do we do here? We draw our normal distribution curve. Okay, so I'm going to draw and label the normal distribution curve. It's like this, something like this. 1 second. Yeah, something like this. All right, now the mean, there's a line in between at this point, then one here and one here, there's a line here and one here. All right, now this is going to be the first standard deviation. So one standard deviation after the mean will fall here, two standard deviations after the mean, and this is three standard deviation after the mean. Okay, now this is ahead. This is all these values are in front of the mean. This one, they're all in front of. Now if we're going behind the mean, one standard deviation behind the mean, two standard deviations behind the mean or below the mean, whichever, and three standard deviations below the mean. Okay, now so we know that this right here is the mean. I hope we have understood that this right here is the mean. Right here, this line right here is the mean. Okay, let me write it. Sorry, my pen is a bit shaking. Okay, now now the amount of patients or the percentage of patients between or around the mean, one standard deviation around the mean, is actually 68, actually 68%. 68% is one standard deviation around the mean. Okay, now the amount of patients that are two standard deviations around the mean is what, 95%. So 95% of patients are going to be two standard deviations around the mean. Okay, now we have those patients who are three standard deviations around the mean. They are what, 99.7%. Okay, 99.7%. All right then. Now okay, now that we have labeled our normal distribution curve, now it's time to attack the question. Okay, our question there was this. Okay, they've given us the mean. Obviously we have the amount of patients here, 400. The mean is 220, and we have the standard deviation as 10. All right, okay, let's go back to that. Okay, so our mean, our number of patients is 400. Okay, Mean is what? 220, and the standard deviation is 10. Standard deviation is 10. Okay, now they're asking how many patients are going to be greater than, how many patients would have an alcohol level greater than what? 240. An LDL, sorry, LDL greater than 240 milligram per deciliter. Okay, now we already know that one standard deviation is 68% around the mean. 95% will be 2 standard deviation around the mean, and 99.7% will be 3 standard deviation around the mean. Okay, so what are they asking us here? We know that one, okay, we might have to draw another Gaussian or normal distribution table to be able to understand it more. Okay, so I'm just going to draw another one right here. Let me just draw it here. Okay, here, this. Okay, now we know that one standard deviation is 10, so that means this is 10. Okay, if this is the mean is what? 220. This is 10, that means this is what? 230. Okay, and that means this is what? 240, because it's all one standard deviation. This is 10 as well. One standard deviation is 10. Okay, another standard deviation is 10 as well, keep making this 240. Okay, now they're asking us how many people will have an LDL greater than 240. We already know that this here is 240. They're asking us how many people will fall within this region. How many people are within this region? Okay, that's all they're asking us. So right here we know that 68% of people fall 1 standard deviation around the mean. You see it here, 1 standard deviation around the mean. We know that 95% for 2 standard deviation around the mean, and 99.7% for 3 standard deviation around the mean. Okay, that means that if we subtract the amount of patients that fall here, if we subtract this from this, okay, we can actually get the amount of patients within 3 standard deviation. Okay, that is within this box, this particular area here. It's very simple. If you subtract this from this, you're going to get the amount of people here. All right, now we only want this, so we can actually just divide it by 2. Whatever value we get, we divide it by 2 and we can get this. Okay, so we'll just, I will explain as we keep going on. Okay, 99.7% of patients, how many patients were there? We had 400 patients, so 99.7 100 times 400. Okay, and I'm actually 99% of 400 is almost 400. I mean, you get what I'm saying? So it's basically going to be about 400. Okay, we don't need to calculate that. That's just going to be about 400. Now the next value is 95%. 95% of 400 will be equal to what? Okay, we might need to calculate this one. All right, so that's 95% of 400 is 0.95 times 400. That's what? 380. So that will give us 380. So that's 380. Okay, so we know the amount of patients within the 97%, 99.7%. We know the amount of patients within the 95%. All we need to do is subtract them. Okay, so if we do 400 minus 380, that will give us what? 20. So that means 20 patients are going to score within 3 standard deviation above and 3 standard deviation below, basically. So now we only want the value for above, because the question is asking us what? How many will score above 240? We only want the amount of patients that will score above that. Okay, so we can simply just divide that value, that 20, by 2, and we get our value of 10. and I can bet that 10 was in that option. Let's check. I think 10 was option C. So yeah, that should be our answer, C. So first thing first, you just have to learn how to approach the question. This is if you can understand the Gaussian, the normal distribution curve. If you can know what values, the values that are there, like this value right here, the 68%, the 95%. If you can know the 99%, where they are located, I mean, you'll be able to tackle such questions when they come. Okay. All right, then let's handle another question now. All right, next question will be 1 second. Okay, this is the question 2. A meta-analysis study of scores in a certain population of 100 USMLE testers shows that the values are normally distributed with a mean of 230 and a standard deviation of 20. 95% confidence interval will lie between which of the following limits? So they are basically asking us for the confidence interval limit in this within this in this study. Okay. All right. Now let's go to the screen. Okay. Now, first of all, let's agree on the formula for the confidence interval. All right. So confidence interval is equal to what? Mean plus or minus z-score into bracket SEM means the standard error of the mean. Okay, where the standard error of the mean is equal to standard deviation over the root of the number of participants in the study. So n is basically number of participants or number of people involved in that particular study. So number n is just number of participants or volunteers. Let's use participants. Okay, good. Now we know that our mean now what was the value for the mean? The value for the mean was 230. Okay, our standard deviation was 20 and the number of participants here is 100. So we know that the mean is equal to 230. The standard deviation is equal to 20 and the number of participants is equal to 100. Okay, and I think we are right. Okay, good. Now they're asking us for the confidence interval. So once you know the formula, I think you'll be able to tackle this kind of question. Okay, so we'll start by solving for the standard error of the mean. Okay, the standard error of the mean here is standard deviation over the root of 20. So standard deviation is 20 over the root of what? The root of the n value, sorry, not 20, the root of n. So the root of n here is 100, so the root of 100 basically, which is equal to 20 over what? 10, and that's equal to what? 2. Okay, so our standard error of the mean is 2. So we've gotten this value now. Now the question now is, what is our z-score? We should know that z-score for 95% confidence interval is equal to 2. Is equal to 1.96, but you could simply just use 2 to make it simpler. All right. However, if it's for a 99% confidence interval, it should be, you can use 3 or 2.59 actually, but you can use 3. Okay, all right. But here they're asking us for the 95% confidence interval, so we're going to use 2. Okay, so we know that the mean is 230 plus or minus 2 into bracket SEM. Our standard error of the mean, our answer for standard error of the mean was 2. Simple. Now we've gotten a very good and standard mathematical calculation here. So that's 230 plus minus 4, right? That'll be 230 minus 4, 230 plus 4. Okay, now that'll be what? 226. So our confidence interval limit will be between 226 and what? 234. 234. All right. Now this value here, this 226 confidence interval is this. So 226 is the lower limit of the confidence interval, and 234 is the upper limit of the confidence interval. Okay. So so 226 is the lower limit of the confidence interval, and 234 is